Hello everyone, welcome to my channel ECE Scholastic. I'm Jasmine. From today's session, we are going to start a new series of topics under frequency response analysis. As an introduction to this topic, we are going to see a few topics under today's session. That is, why frequency response, what are the basics of frequency response, and what are the characteristics of frequency response. So let's start the session with the first topic, why frequency response. The first reason behind frequency response analysis is the real world applications are governed by linear differential equations. So in order to find the solution for the linear differential equation, it is very difficult. So we will be converting the linear differential equation into an algebraic equation with the help of the frequency conversion techniques, and later we will be solving the expressions to find a prescribed solution. Okay. Second important thing is the complicated transfer functions can be experimentally determined with the help of this frequency response analysis. Next is we can obtain a steady state response with the help of this frequency response analysis, or in other words we can say we can tell at which range the system is stable. Okay. The next important thing is application. Okay, so this frequency response analysis is widely used in the areas like communication, geology, remote sensing, image processing, speech signal processing. So wherever the frequency is applicable, in all those domains we will be using this frequency response analysis. Okay, see, I have shown you an output frequency curve for an audio speaker. Why we are going for this frequency response? So within a certain band of frequencies, we can find from which frequency to which frequency the system is providing a better performance. Okay, and which is the highest peak frequency. All those details can be analyzed with the help of the output response curve. With the help of a single frequency plot, we can see a number of results. Okay, so we can split all the results separately with the help of time domain analysis. Okay, now let's see what is the difference between this time domain and frequency domain analysis. So in a time domain analysis, we will be identifying how the signal changes with respect to the time. Now what about this frequency domain analysis? So this frequency domain analysis talks about how the energy is distributed for this particular range of frequency. Okay. So in a frequency domain analysis, we will be considering a linear system. So to the linear system, if we are giving a sinusoidal input, so sinusoidal input has a frequency, right? So we will get an output based on the input. The concept is only the frequency of the input and the output remains the same, whereas the magnitude and phase of the particular plot varies. Okay, and say that only two parameters is getting altered. One is the magnitude parameter and the other one is the phase parameter. So the output of frequency response will be represented with the help of two plots. One is a magnitude plot and the other one is a phase plot. Discuss some basic things under frequency response. Frequency response is the magnitude and phase function of a sinusoidal transfer function of a system as a real function of omega. Okay, so in a system, if we are having a transfer function as T of S, then in the place of S, we are going to apply j omega, or in other words, we can say S is replaced by j omega in order to calculate the frequency response of a open loop and closed loop system. Okay, so for a open loop system, what is the transfer function? G of S is the transfer function. So I am replacing S as j omega to obtain the frequency response. For a loop transfer function, our function is g of s into h of s. So in order to obtain its frequency response, I am replacing s as j omega. Therefore, my expression will become g of j omega and h of j omega. And my closed loop transfer function is m of s. So in order to obtain the frequency response, I am replacing s as j omega. So I get m of j omega. We have one more expression for closed loop, that is c of s by r of s, which is nothing but m of s. Okay. As I told you previously in the introduction part, the frequency response completely talks about the stability of the system. Therefore, the absolute stability and relative stability of a closed loop system can be obtained from the open loop system. That is the main characteristics of a frequency response analysis. Before explaining the next characteristics, let's see some basic terms, that is transfer function, complicated systems, design analysis, parameter variation, noise disturbance. I'm going to combine these two terms, that is, the transfer functions of a complicated system can be experimentally verified with the help of this frequency response analysis. That is our next characteristics. Next is the analysis and design of a non-linear systems can also be identified with the help of this frequency response analysis. So in the first part itself, we have shown that it is only applicable for linear systems, but we can extend this to a non-linear system. So the noise disturbance and parameter variations in a system can be detected and corrected with the help of this frequency response analysis. The final point, the practical testing of a system can be done with the help of sinusoidal generators and precise measurement equipments. Okay, so that's all about the characteristics of frequency response analysis. So as a conclusion, I can say that frequency response analysis completely talks about the stability of the system and the distribution of energy over a particular band of frequencies. Okay, thank you. If you have any queries, please mail me. Don't forget to like, share and subscribe. Thank you.